Okay, so we managed to get the driver's side motor mount sort of mocked up in there, if you will. Got our 1/4 inch plate bolted to the subframe, which actually ties into this rail that's going down here. And then we've got our mount bracket tack welded to that and our cushion in there. And everything's sitting just where it's supposed to be. So that's one side done. What we've got to do now is rip everything off the other side, which is going to be a little more complicated. We're going to have to pull the alternator off and probably the radiator hoses and a lot of other stuff over there to get at the area where the mount's going to go. It's going to go down in there, and probably going to have to re-engineer the alternator mount, so it's going to be quite a bit more work on that side, but we'll figure it out. You know, as with everything else we do, it seems like we take one step sideways, 2 steps backwards. So we had our fuel gauge, which was non-functional. And then we thought we got it to function, but all we got it to do was make the gauge go completely off the other end every time we turned it on. So now we've got everything out. We got the sender out because we were trying to test it and weren't getting any kind of a signal out of it. We got to take it apart. And right here on this board, there's a little tiny wire that I can't hardly even see that needs to be soldered to that contact. And then this is the resistor. And as the float has a little arm on it, a little pickup goes back and forth across that resistor, that's what signals how much fuel should be registered on the gauge. More or less resistance means more or less fuel. So now what I got to do is see, I don't know if we can even zoom in. You might be able to see that little fine wire right there needs to be soldered onto that contact, and that wire, that lump of solder that's there, is the wire that runs up through and out the top of the sender and is the signal wire for the gauge. So in other words, I don't know, if you go all the way one way, it's fully grounded, and if you go all the way the other way, there's resistance and a voltage drop to the gauge, and that's what makes the gauge work. So you have basically the sending unit grounded, and then you have that second wire that's insulated, and that's how the gauge gets its signal. It's all hocus pocus magic, but I still don't know if the gauge is good, but I can't get anything until I can be sure that, first of all, the sender's working, and second of all, that the resistance in the sender matches the resistance to the gauge, because, these gauges, there's a bunch of different combinations, and you have to have a sending unit that works within a specific range of ohms to match the gauge. If you don't, nothing works right. So I gotta go get my magnifying glasses or something and see if I can figure out how to solder that wire on there. Okay, so our parts order came, and we got a new sending unit here, and this is a VDO sending unit, same as the old one. This one, of course, has already been shortened up to meet the needs of our specific fuel cell. This one is adjustable, I think, between 6 and 24 inches. And, of course, this is where the float goes. You have a stop that way at dead full and a stop that way at dead, I guess this would be full this way and empty would be that way. What we're going to do now is we're going to hook up our ohm meter and see how this unit works. So I don't have enough hands to do this the way it should be done, but let's just say at dead empty we're reading 8.8 ohms, and at dead full, well, 190, somewhere in that neighborhood. I keep losing connection, but 190 ohms. So this sending unit is supposed to be 10 to 180 ohms, and it appears to be working okay. So now what we want to do is get our fuel gauge and sort of make a system here that we know we have a good sending unit. We see if we have a good gauge. Somewhere, somehow, the video clip of our benchtop test of the fuel gauge system got eaten by the video squirrels, so we don't have that. We have put everything back in the car multiple times. At one point we blew a fuse and had to figure out in the conglomeration of wiring where the fuse was. We got that sorted out, and then the float seemed to be hung up in the fuel tank, so we had to take that apart and fix it again. So at least now, let's see, maybe if we turn the key on, our fuel gauge works. And there you go, success. It's really just a case of making sure that everything is connected properly and working properly. In our case, the sender was bad and it really wasn't wired properly. So the gauge has a positive terminal, a negative terminal, and a sender terminal. And then the center post and the sender of the unit is insulated, and that connection goes from the sender to the sending post on the gauge. And then you have to make sure that the sender unit itself is grounded. In this case, the fuel tank is plastic, so we had to run a separate ground for that. And the gauge is grounded to the same source, in this case the car, and you have power. And if you have all of those things and you can replicate them on the bench, then your gauge should work. And in our case, finally, it does.